So now we have a rough idea as to what is the pressure exerted by the liquid. As we have seen in our previous examples, how the different layers of liquid or fluids exert pressure one up to the other. That is, the above layer exerts pressure to the layer below, and the third layer is experiencing a pressure because of the weight of the above two layers. So this is what we can understand regarding the pressure of liquids. Now Pascal's law, if you now Pascal's law tells us that if the liquid is at rest, if the liquid is at rest, then that is in this particular system, let's have a imaginary system where there is liquid. Now Pascal's law says that if the liquid is at rest, that is there is no motion of the liquid, no motion or movement of the liquid. So what you can understand is that the pressure at any point of the same height, the pressure at any point of the same height. Say suppose this is your point A, this is your point B, and this is your point C. Now all of them are in the same depth, or you can say in the same height, say H. But they are of different point, but what we know is they are of the same height. Even though their location is different, but the height of the liquid above them is same, that is H, 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 and all this liquid are of the same material, that is the liquid is same throughout. So at that moment of time, what Pascal observed is that the pressure if the liquid is at rest, then we can say they are equal. They are equal. So this is what a physical understanding of Pascal's law, that is the pressure experienced on A, on B and C are equal provided the height, that is the height from the top, are equal. Now if you want to form this into a statement or definition for your examination, you can form it in this way. Pascal's law states that use this as your definition in examination. The pressure in a fluid, the pressure in a fluid at rest, provided the whole system is at rest is the same at all, is the same at all points if they are of the same height, if they are of the same height. So this is what we know of Pascal's law. Now let's see how there is a variation of pressure with depth. Let's have a look. Now let us suppose we take a container and we fill this with liquid. Now for a height, say for a height H1, the liquid that is above this particular height is, for this particular height, all the liquid that is above it is mass. First the mass of the liquid that is above this into the weight, that is acceleration due to gravity. Acceleration due to gravity. Okay. So the force that this whole line is experiencing is the total mass m, and acceleration due to gravity. So this is a total force that this layer and the layers below are experiencing because of the above mass. Now this mass can be converted into, say suppose we are considering layer by layer. If you are considering layer by layer, then this layer into a height h, So if I am considering this layer to be my mass, this is my mass. Now I want a total of this area. That is, this is the total liquid that is above the point A. So what is the total weight of the liquid above the point A if one of the layer is of mass m? So that is easy. All you have to do is mass m into your height. This will give you the total mass of this particular portion, m into h into g. So this is what you can understand, that is the pressure or the force that the above layer is giving. So now if you look closely, P2 minus P1 is actually, if this is pressure 2 and this is pressure 1. Now say suppose we take in a container, if you take in a container the point P1 and the point P2. Now what is the difference in pressure between them? So if I take this cross-sectional area, so the pressure at point 1 and pressure at point 2 is nothing but P2 minus P1 into mg upon A, that is the area of cross-section. So now let the density of water be rho. Rho is the density of water. We have taken density of water to be rho. And this is the density of the water. Now we are taking a straight line. So only the unit area density will be there. Now we are not considering the whole part. We are just taking this point. So this is your rho. This is the density of water. Now density of water into h, into height h. So what is the height over here? What is the height at this particular point? What is the pressure due to only this point? Only this point P from here to here, that is the density into h. So this will give you the total mass, density into h, into acceleration due to gravity will give you the force that is responsible for this height. This is your force. So pressure, if you divide this by area, that is by unit area A, you can easily say that P2 minus P1, that is pressure, is equal to rho GH. Rho GH, mass is rho into H. This mass is rho into H. And A, why have I neglected A? Because I have taken unit cross-sectional area. A that has been taken is unit cross-sectional area. So this is A equals to, say suppose 1 unit. Therefore length is 1 unit, breadth is also 1 unit. So area equals to 1 into 1 equals to 1. So A I have taken as unit cross-sectional area for my calculation. So the pressure is given as P2 minus P1 equals to rho GH. Therefore at this particular point we can assume that this is a pressure because of this two. Now a similar pressure, what is P1? P1 is a pressure that is experienced due to this height, from this height to this height. That is, say suppose H2. Say suppose this is height H2. So what is P2? P2 is the pressure experienced for the water above 2 here. So minus rho G H2 is equal to rho GH Let this be H1 into P2, pressure at this point, P2. Sometimes you have added an extra P atmosphere because the atmosphere is exerting pressure over here. So for now we are excluding atmospheric pressure. So therefore P2 is equal to rho G H1 plus rho G H2. Now rho G H1 plus H2. What is H1 plus H2 is the total height. That is your H. Say H naught. Therefore pressure P2 equals to rho G H naught. And this is the height H naught from the top till the bottom. So now we know the pressure variance is related with the height, the water density and force of gravity. So pressure at any point at the depth of H can simply be given as rho G H. So this is how we can calculate pressure.